What does a mathematician have in his garden? Natural logs, roots, and stem and leaf plots. So that leads us to today's topic, which is stem and leaf plots. Let's go ahead and as well as many others, including dot plots and histograms. So let's start with dot plots. We've been using these already. So there's not a lot of new stuff. You use it when you have one variable. And for your z-axis, you draw a horizontal line with an appropriate scale. In this case, our min is 1 right here. So if I get my pointer, there we go. My minimum value is 1 and my maximum value is 12. So that's my scale. You want to start at or just before your min and end at or just after your max. Your y-axis is just the count or frequency. So I usually use little x's, but a lot of people do dots because it's a dot plot. And there you go. The queen bees, the number of queen bee partners during a mating flight, you can see is sort of centered around 6 or really centered around 7. And she does tend to have a few mates there. All right, so let's move on to comparative dot plots. You really don't want to have both dot plots on top of each other in the sense like they share the same axis, but you do want them above and below each other. For example, this is some data on graduation rates for basketball players and athletes. And so you can see that the basketball players are doing better than the athletes. So again, you can do comparative dot plots, one above the other. Now histograms, we've been working with these a little bit. First of all, we have some options for the x-axis. Bars are the same width, all right? And each bar represents one value, or you can use bins of the same size to lump different values together. In this case, these bars each represent one value. There are no spaces between bars on histograms. Now on bar charts, which are for categorical data, you do have spaces, and the reason is you can have them in any order. But on a histogram, you have a specific order, so there are no gaps between it. For the y-axis, you basically have two different options. You can use the count or frequency for the height, or you can use the percentage or relative frequency for the height. Now, the tricky part on histograms is when you have values that aren't so pretty. For example, here's carry-on baggage weight. And so how do we determine the number of bins we're going to sort this in? So this is a nice guideline I ran across. We can use the square root of n, where n is the number of data points, to estimate the number of bins. Well, we have 25 data points here, which means we are going to have square root of 25, or 5 bins. Then I need to know how far apart the data is spread. So I need to calculate the range. So I go max minus the min. 34.5 is the maximum value up here. And 10.1 is the smallest. So I subtract it, I get 24.4. It's helpful to round this up so it's divisible. And you can see, what if I just use 5? 25 and 5. And so to find the bin size, I just go 25 divided by 5. Then I create the bin boundaries, which are basically, there's my bin size, it showed up late. I create the bin boundaries by starting at my lowest point, and I can start at a nice clean spot like 10 instead of 10.1. So the bin sizes I'm going to create are 10 to 15, 15 up to but not including 20, 20 up to but not including 25, 25 up to but not including 30, and 30 up to, and actually I could include 35. It wouldn't be a big deal if I had 35 there. So pick a start point a little at or a little before your min, and just add the bin size to determine the bin boundaries. So in this example, you can see here the different categories, and we just piled up the data points in there. So it's a lot like the other one, and you can see this is the bin from 10 up to, but not including 15. This is a bin from 15 up to, but not including 20. Now, let's take a look at the queen bee histogram again. We could actually bin that one. So first of all, the way I have it here, the bars are centered on the values because each bar is just one value. They're discrete and unique. When I create the bins, then the bar is going to set. So here it starts at 0.5, not that you have 0.5 mating flights, 0.5 partners. Poor guy, he was probably cut in half. But anyways, so you just cut in between. And so this bin covers from 1 to 3 mating partners, 4 to 6 mating partners, 7 to 9. And you can see that the shapes of the distribution are going to depend on how you pick the size of the grouping intervals. Now, another thing you can do is you can use your calculator to create histograms. And I know I've shown it to you briefly, but I'm going to take it another level. So first of all, you have your data entered into a list. And I took some data actually from your textbook and I entered it in the list. The next thing you're going to do is you are going to press second stat plot and choose plot 1 and hit enter so you can edit it. Make sure that plot is on. And then you want to make sure that you are on histogram, which is that top right. So make sure the plot is on and you select histogram. Make sure other plots are off. Press graph, and if necessary, I've already zoomed it here, so it's not so big a deal. Zoom stat. Now, I could have just pressed 9 here instead of scrolling down. And there it is, it's zoomed in. Now, these data points, usually the calculator is going to make something funny. So we can change these to nicer data points. We're changing the min to -6, the max to 6, and the bin size to 1 here. So then we can graph it again. And now this is going to give us pretty bins, and I can hit trace to see the various values that are on that histogram. So your calculator can be quite useful in generating pretty histograms, especially if you use window to set your min, your max, and your bin size. Stem and leaf plots, I like to use these to show grades because they take all the identity out of it and you can see where you stand. And so you've seen these before. You learned them in 6th grade. So the stem is a leading digit or digits for data points that share those digits. In this case, I'm looking at quiz grades, so I'm going to look at the 10s place and higher. Those will be my stems. So sadly, the lowest quiz grade was a 10, so I will need a 1, going all the way up to the 100 that I have there. So I need a 10 for the, I have a 10 in the 10s place because 10 times 10 is 100. The leaves are just the ones, and by the way, these go on the left side of the column. The leaves are just the trailing digit or digits because if I'm dealing with bigger numbers, I can have more than one place value there. And they're for each of the data points. Now, if I didn't have such a wide spread already, I could actually split these up like from 0 to 4 and 5 to 9. But I didn't. I just left them as they were. And you can see there are the values on the right. So I had this first data point represents a 10. The second one's a 10. The next one's a 15. Here's a 20 and here's a 25. So I can see these students really need a lot of work on their graphing skills. Yeah, this is for a line, y equals mx plus b. Whereas these students had still remembered how to do it from Algebra 1. Now, it's helpful if you list it in order. I think I've seen it somewhere where it wasn't in order, but just put them in order. Life will be better. And you do not need to put commas between the leaves. Just try to have them line up, kind of grid-like. You also want to be sure that you have a key for each of your stem and leaf plots, and they will be looking for that on your AP test. Now, you can also do a comparative stem and leaf plot. So let's say I wanted to compare 2 classes side by side. So the center column is going to be the stem, like before. The left column is for one set of data, and the right column is for the other set of data. And you still have your key like before. Be sure to include group labels so you can distinguish the data. So I know that first class I'll just call class A here, and the other class I'll call class B. Now the last type of plots we'll be looking at are time plots, but you're kind of used to these. These shouldn't be too difficult. Basically, you're graphing the value over time. So in this graph, we're looking at the average public tuition, average tuition and fees, and one's public in-state, that's the orange. The blue is public out-of-state, and the green is private. And so you can see how tuition and fees are changing over time for college. Kind of scary since I know you guys are going pretty soon. All right, now what I'd like you to try, and this is available on the website too, weigh some pennies and plot the data using a stem and leaf plot and also a histogram. You can use this set of data, this data set, or you can weigh your own pennies and tell me what you find. Something else for you to try, and I'll put a solution up. Create a stem and leaf plot of the following display, of the following data. And there are different ways. If you use just the first digit down here, it's going to be a little awkward. So you might want to consider not limiting yourself to the first digit when you make this stem and leaf plot. And then finally, there are 3 problems in your book, which I think would be quite helpful here. Problems 11, 15, and 19, and the answers to those are in the back of the book. If you have questions, please bring them to class for